Hello everyone, it's August 31st. So, the two things interesting today. The first is my advisor shipped me a new laptop. I think it's M1, and my old laptop is a 2014 MacBook Pro. So, I'm trying to figure out if I can just do the time machine and then restore it in the M1. But from what I have read, it's very risky. So, I probably won't do that. And which means I'll have to transfer all the files manually. Oh God, just the idea, like thinking of it, just make me very, very uncomfortable. Oh my God, I have lots of files. Like it's not like a single file; it's a ton of files. And I just realized one thing: I do have all the files on my time machine, so the transfer won't be an issue. What will be an issue is I don't the the hard drive I use for Time Machine only has USB-A, and I don't have an adapter to get to USB-C because I think the MacBook Pro only has USB-C. Lord, this is not looking good. Honestly, this is not looking good at all. Oh, there are other issues. I need a USB-C cable. Anyway, so yeah, it's exciting and not exciting at the same time, but we'll figure it out. We'll do the transfer. When the old MacBook Pro, it's not working, and it's very powerful in terms of memory and storage, but I think the CPU is just not catching up. Yeah, it's just too slow. I think I'll turn that into my game laptop. I do have a boot camp set up so I can play game in Windows. So that laptop probably become a game laptop. And so that's one. And the second thing was I trained earlier, so I can start doing this earlier, which I think is important. All right. All right. Anyway, so that's just today, and the fan is on. That's why there's a lot of noise. Oh, we're heading into September. Wow, time really flies. All right. I have the Ghana today. Let's finish this and do the minimum jump. I give the minimum jump a little bit more thought. So I think I know where I got it wrong the last time. But anyway, let's try this one first. Given a binary tree, a node x is good if in the path from root to x there are no nodes with a value greater than x. In the path, so everything has only one path. It's a binary tree. Okay. Return the number of good nodes. Oh, the root is always. Yeah. So what? We just traverse the whole thing and keep track of the biggest value along the way, right? So we traverse and we keep track of the biggest value, and this is not, and this is good, right? And then there's a 3 is good, so biggest value is 3, come here is 4, 1 this is not, 5 this is. So we just do a traversal, and you see that this is, it's considered as a medium, right? But actually this is not really that hard. We go into September. I think we have figured out that to reach 1,000 days, that's basically next May, I think. That's also when I'm going to graduate, hopefully. So by the time I graduate, I will be able to hit 1,000 days. Man, I can't wait for that to happen. But getting back to, like, I haven't touched my research stuff for 3 months. And now I have to get back to it. And I'm telling you, it's really, I'm dragging my feet on this. Like, I know I have to do it, but there's just so many things that I've done in the previous semester, and it's just hard. It's very difficult at the moment for me to really get back to it. But I have to. It's just, these type of things, right? once you get started, once you are really get your mind ready, yeah, you can do it. But before, like the process of getting started is always tough, very tough, at least for me. Okie dokie, so I don't think we can do this, so I'll do a DFS, right? I have a node, I'll just go tree node, and current max. What do we return? I'm gonna return none. Usually it's easier to do something like this. Alright? And then, what do? We say, if node, right? If not node, oh, yeah, then we just do optional, right? If node, if current max is smaller or equal to node.val, self.rest plus equal 1, and current max equal to node.val, right? Then we do DFS node.left current max, DFS node.right current max, and say DFS root. We want a smaller thing to start with. Everybody is larger than 1, so 0 will suffice. And then return self.rest. I think this shall be sufficient. Give this a shot. If it's not right, I'll debug later. Looks promising. Do we have edge case of... Oh, hold on. My bad. Number of nodes. My bad. We need to do math.inf. Yeah. Because if I do a -1, it's gonna error out. So we have to do a minus math. You see that? Because of this one. But if we do minus math.inf, it will work. Alright, let's go for it. Yep. Nothing more to say. So it's a simple question. 790 days. Good. 1448. Yeah, with OM. That's all I need to say. Alright. So let's back to this thing. So I was wrong because in this scheme, if you see, I say if it's forbidden, then I'll break out immediately, right? That's actually not right. Because there are two things that needs to be worked with. The first thing is I shouldn't go the first row because the first row can go infinity, okay? So what I need to do is do the first column because in the column I'm minus, right? I'm minus, minus, minus. So there will be an end. So we're going to do column by column, right? So as I'm doing a column, if something is forbidden, that just means in this column I cannot continue. That doesn't mean the next column will fail, right? Because each value can be reached by, like we're talking about a forbidden value. We're talking about a value that will be generated from a forbidden value. So this value, it can be generated, let's say by minus, from forbidden value minus. It might also be generated by a non-forbidden value plus. So if we meet a forbidden value, we shouldn't disable both the column and the rows. We should just disable whatever direction we're going, and the other direction shall still work, which means things like this, right? I say if it's forbidden, then I break. That's not accurate, because if it's forbidden, it just means horizontal, it can now go, but it doesn't mean like everything to the right, it doesn't work. But it doesn't mean those values cannot be get from a vertical standpoint. So with that in mind, I'm gonna make significant change to this. So what we're gonna do is I'm gonna do vertical first, right? So what we're gonna do is do vertical, and then we're just gonna go drop down from, and we're not gonna do from 0, all right? So we're just gonna do next one, right? Then we're gonna drop down, and we see what's a catch, not a 1. We're just gonna add, right? And we're gonna go down, down, down. If we got forbidden, we just skip out, and we do the next column, and we just go down, 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 down. And if we hit a forbidden on a row, that's a good question. So we're doing down. If we get forbidden, we just, we cannot go down this column anymore. We'll go to the next column. And what if we hit a forbidden at the start? If we hit a forbidden, I shall keep going. If there is something on the previous column, yes. Yeah, we can keep going. We shall keep going. Like if we hit a forbidden, we just skip it. We put that into 0. We put that into, not a 0, put that into -1. Put it into negative values, right? We put that in negative value, and we keep going. And as long as there's something to the left, I can still do it. And then we can still go, yes. And then we just do this until we until we either cannot go anymore, or we find the target. Okay, I'm gonna try this idea. So dp, we can just call it, not call, we'll just call it column, right? So column is going to be minus. And none of this will do us any good, so I'm not gonna even bother it. Okay, so this is the first column, all right? Then we go to the second column. So j is equal to 1, second column. And then we say while what? Column, right? While we have something to go with, right? While column, we say temp equals this. And then what we're gonna do is we can go while true. That's while true it. And we have I. Do we need I? We don't even need I. We're just while true. Okay. Then we need to say say what? We look to the left, right? We say if column I need I is gonna be 0. Oh, I might be able to use a len temp. Let's try len temp. All right, column 0 is larger or equal to 0. And hold on. Let's do this. I equal to len temp. Okay, and then I'm going to say if len column, right? Because we want to do column I. Okay, so len column has to be larger or equal to, no, larger than I. It cannot be equal to I. So this has to, if this, if it's not, then we shall stop. No. Hold on. Let me think again. Come on. You can think again. So we need to either go from left to here or go from top to here, right? So we try left first, right? Then we say, how do we try left? We say if column is larger than I and column I is larger than 0, and that means temp.append, we can go plus, right? Which is column I plus, was it plus A or plus B? I don't remember. Plus A, right? We say, we should say val equals this, right? And that's going to the right. Else, which means either column it doesn't have I or it's forbidden, then we try to go from top, right? So we say elif hold on. No, that's right. Elif temp, right? Elif temp and temp, the last one, is larger equal to 0. Then val equals temp this minus b, right? Okay. Is there another situation? I don't think there's another situation. Well, what if nothing else? Else value shall equal to -1, right? Then we say if val in forbidden, hold on. Right, and we say if val in forbidden and we shall stop if value is a negative value. Actually, because we have two signals, right? One signal is to indicate this column is done. Now, when a column is done is if a value becomes negative. And if it's forbidden, maybe we should use math.infinite. Let's import math. And let's say, what's this? This is just all right, we do this, or we do this. This means there's no way to go. All right, this means no way to go. And forbidden is going to be minus. Okay, then we say val shell equals minus math dot infinity. So once we handle all that, then we check, right? We say if val is smaller than val and then smaller than 0, right? If that's the case, then we're going to break. That means naturally we hit a point where we just cannot continue. But if we hit minus math dot infinite, that means we should keep trying. So this one going to break. When we break out, we're going to say column equal to temp, and then we try it again, right? Then we try it again. Oh, so if this, then we break. Otherwise, right? Otherwise, elif, say val is equal to x. So we got it. Then we shall return the step. Well, we have j plus len temp, right? Because let's say yeah, I think just plus len temp because I haven't added yet. Else, that means we shall add it. So temp dot append val, right? And then coming out, j plus equal 1. And we go back up. And we keep going. And when we escape, we say return once. All right, let's try this. Okay, we pass quite a few, but we fail in test number 1. All right, deserve a closer look. 25. 12 plus 13. Yeah. Probably should print this. I think I still have it. 0, 15. Hold up. So we have 0, right? 15, 2, 30, 17, 4, 45, 32, 19, minus inf. Oh, minus inf, I shouldn't even put it in. Huh. Oh, minus inf, I do put it in. Because when we want to try. Yes, minus inf, I do put it in. Then we have 60, 47, 34, 21, minus inf. What's next? 75, 62, 49, 36, 23, and 10, 90, 77, 64, 51, 38, 25, minus inf, 105, 92, 79, 66, 53, 40, 27, 14, and 1. 120, 107, 94, 81, 68, 55, 42, 29, minus inf. Huh. I didn't even get to 11. Of course, because I return right here. There we go, the last is here. Anyway, so $135, 2, 370, 7, 4, 1, 18, 5. All right, 50. 35, minus inf, 35, 50, 22, 9, 37, 24, 11. So my path is go all the way here and go all the way down. Did I miss a forbidden? Oh, come on, man. Come on. It cannot jump backward twice in a row. How did you miss that? Seriously, how did you miss that? Okay, so that means we have to do zigzag. But even for this zigzag, right? Then we see how many downs we need. Right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have to do 13 downs, right? And we see if we can split out 13 downs. Yes, so when we meet, we'll always be here, right? Then what we need is to know if there's any forbidden. If there's no forbidden, then yes, we can just zigzag down, right? We can always write down, 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 write down. Write down, write down, write down, write down, write down, write down. Wait, hold on. something is not right. 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I missed a column. No way I missed a column. No, I didn't miss a column. I missed something. Wait, hold on. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, it's supposed to be 13. 1, 2. Go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, that's... I see. If the amount of down is more than the... Because the best we can do is... Because I cannot do 2 consecutive. So to do a down, we have to go right first and then go down, right? So the best we can do is zigzag down. And initially we cannot go down, so we just right down, right down, right down, right down. So the amount of down at most should be the same as the amount of to the right. And the amount of down can be smaller than the amount of to the right. We just do more right, right? Furthermore, if like some length, how do we analyze this? It will have something blocking the way. Let me think. If we have something blocking the way, which means in that position we just cannot reach, right? Do we have to literally also traverse this thing to see if it's possible? Man, we might have to. Like, how do I know it? I can do it. We can traverse because each time we only need to do 1 down, right? If we do 1 down, that just means if we only do 1 down, that means at the beginning we can say I will do right down, right down, right down, and then do all the way right, trying to reach it. And if it works, perfect, we're done. If it does not work, like we have a block, that means the last stretch cannot be this, right? That means the last stretch cannot be this. So we'll go here, then go to the last stretch. If we block here, then we're gonna try to do the last stretch here. Man, doesn't this feel convoluted? I feel I'm getting close, but like, what if we have infinity inside? That's my question. If there's something inside, then we can affect the route that we can take. Or can we say is always a way? I don't know. I don't think so. Or we can say if we can keep going. Because we'll block out if we cannot keep going, right? If we can keep going, that means there is a path. Yeah, that means there is a path. Okay, I mean, take a faith. So my faith is this, right? So we're just gonna say the amount of going right has to be larger or equal to the amount of going down. But what if they're equal? And then we have, yeah, in this case, if it's equal, let's say if we hit here, right? Then we cannot get there. We hit infinity. Right? We hit infinity. If we can note where the infinity is. Okay, let's say we note where the infinity is, or where the impossible ones are. Okay, I know that. And then we know we have to go down how many steps, right? Yeah, because we have to go to one at a time, and we just see if those infinity will be hit or will be encountered. So basically we say, okay, if I go down, yeah, I have to go down, which means I have to hit those individual indices. So the question is whether we will hit the infinity when we go down, right? That's the question, whether we will hit those infinities. So I have that. So if I go down 4 times, so I have 1, 2, 1, 2, 3, 4. Right, we'll go 1, 2, 3, 4. So 0, 1, 2, 3, 4. Those are the indices. So let's see. Okay, if I have basically I'll have bunch, right? And then we have all the impossible position, right? And then we just say if the impossible position, can we avoid those impossible positions, right? That's basically the question. And depending on how many downs we need to do, right? Because we have those impossible positions. And then if we have smaller number of downs, then we can choose where we do the down, right? We can choose where we do the down. So if we have an impossible position, which is the same as that, then we can say, okay, can we avoid it? I still can't figure it out. How many we have, right? How many do we have? And all we need to know is whether it's possible to avoid those positions. Yeah, that means at these positions, we have four positions we need to go down, right? So I just need to find if there exists 4 columns that at those positions, there is no minus infinity. Okay? So of course, if as long as we have 4 columns that can afford us with this, right, then we're good to go. Then we can have each column, right, each column, if it's empty, that means there's nothing. Or we can have the value, like where they have. Then we just go through this, right? We're gonna go through this list. If it's nothing, then good, we remove one. We're gonna go like 4, 3, 2, 1. If it's nothing, we pop it. If this catch it, then oh, nothing. If not catch it, pop it. Okay, this might work. This might work. Hold on. So we still do this thing. This thing is perfectly fine. Now what we need is a way to what? The forbidden impossibles, like the position of impossible. Impossible J. J's gonna be this. Okay. So our column temp equal this, right? Then we say impossible J start append and this. Actually, let's do a set. Okay. And we say while true, this blah blah blah, and then we say if value is in forbidden, then we say value equals this and impossible this minus 1 dot add J, right? No, I. Oh, I, it's not J, it's I's. Is I. Row index of all impossibles for each column. And impossible I. Right, impossible I. Yeah, we'll add I to it. And then if for another one, we just add another one, and then we move on, right? So once we find this, once we find X, now we can say if len temp, this is the number of time moving down, is larger than J, number of times, so we can never do it, then we'll return -1. All right. Must involve 2 consecutive left jumps. So can't do that. All right, otherwise, then we have to check the impossible I's, right? Then we can say the drops equals for k in range len temp, right, all the way to 1, so the 0. Oh, why don't you list this thing? That's the drops. And then we say while drops, right? No, actually, I can say for impossible right? In impossible I. And then we just check out one by one. If drop -1 not in impossible, right? Which if it's empty, that is not in impossible. Then drop dot pop, which means we can do this. And if it's in, we just keep finding. Once we're done, we say return j plus len temp if drop, if not drop, else -1. So this is to check, right? Check whether there are some columns where we can do a left jump without hitting the forbiddens. All right, so that is the new one. So I'm gonna run this, and this one passed for sure. Of course it passed because I know it will pass. Okay, I'm gonna cancel this, run the others. What? Drop is not defined. Of course, it drops. What? Index. Oh, if. If not drops, break. Okay, so let's do this. All right, newly try. Come on. No, timeout. Oh, crap. How many do we get? Oh wow, this problem is tough. Oh, we just started. No. Okay, I feel this is not right. I feel like we have to, figure out something else. We cannot traverse like all of them. That's the thing, right? We cannot traverse all of them. I mean, we can build up this map, which is totally fine. But then if we want to traverse, like we know the target, okay? So we know the starting point, we know the target. The question is if there exists one path that can reach the target, right? And then what we do is we just try it. So we go, so basically just we need to change where we do the drop. So we do a right, right? And then at each position, like we can decide if we can do a drop, then we try it. So we do a drop and then we keep going, all right? And after we do a drop, we just move to the right. Okay, so each step we will do a drop and we do move right. And then we have a drop, we just do a drop or move right. And if we cannot move drop, we just move right. Right. So yeah, every position we can have two options, either go right or go down. And if we have no more go down, we just go right. And if we hit obstacle, then we go back. If we cannot go back. And if we can go down and it fails, then we just go right, then we go down. Maybe that is You know what? Change my mind. We will just do column until we find it. What if we never find it? No, I don't think so. We will find it. Okay. Let's do one more push. Matt. Oh, you gotta be kidding me. It will be very difficult to do it because I'm doing column first. Damn. That's fine. It's okay. We're just gonna be column on the rows. Oh yeah, we do rows. But rows is going to be minus. How dumb you are, man. Yeah, we'll just do this. And we don't worry about all that. And we just, okay, while true, okay? Temp is this. Now we don't worry about any of this. And then while true, right? So what do? We will just add, right? We add, so this one will be mat minus 1, right? So that's the previous row, 0, plus a, okay? Then we say while temp minus 1 is larger or equal to 0, temp dot append temp val equals temp minus 1, right, minus b. And we say if val is larger or equal to 0, temp dot append val, else break. Because this always work, right? And then actually we can just while true, it's fine, right? Once we break, we say mat dot append temp. Okay, so with this, we just choose someone to work with. Let's choose this one to work with. I'm just one for row mat print row. The heck? Infinite loop. I forgot. If temp, then we do this. Oh. My bad. When we find it. If val, if if val equal to x or val is smaller than 0, then we break, right? When you break out, if temp, yeah, temp will always be there. So mat.append temp, and we say if temp minus 1 is equal to x, when break. There we go. What? Oh, yeah. For this one, it's true. We can never go down. We can never go back. So now for this, going right is a left jump, right? So maybe this is not a good example. Let's try this one. Yep, going right So we start from the beginning, and every one will go right first, and then cannot go right, we'll go down. Okay. So this is build up the matrix. Right. Oh, then we can do some check. Yes, we can do some check. How do we do check? So the total, I can actually say if the total going left, which in this case is just going right. So if len mat -1 is larger than len mat, the amount of, if that's the case, then we'll return -1. This is to handle this case. Yes, this is to handle this case. All right, now let's do this. dfs, okay, I and j. All right, and I want to return a Boolean value if it succeeds. And then what? Then we say we add I and j, right? We add I and j. Then we will go right first. And if we cannot go, if we can go right, then we go right. So how do we decide? We say if go right, which means j plus 1 is smaller than len mat I, which means I can go right, and mat I, right, j plus 1 is not in forbidden, which means I can do it. Then I will say dfs I and j plus 1, right? I always try to go right first. Oh, but once I go right, then the next one must be go down. Hold on. Wait. No, I should always try to go down first, which is the right one, right? We go down first, then we go right. And if we cannot go down, then we have to go right. Okay, we need a previous is pre a left, right? Is previous a left? Num of left remaining. So we always try to go down first, which means just go right first. And we say if temp I and j is equal to x, return true, right? Otherwise, we should always have I to go. Actually, no. If we have no more I to go, we cannot go down anymore. That's so if I, let's do m equals len mat. If I is, hold on. If I is equal to len mat, return false. Otherwise this, right? Temp. What the hell temp have to do? This is math. Okay, so it's not X. Then we can ask the question of whether to go. We say if mat I plus 1 if or mat ij is in forbidden, return false, right? Otherwise, we check if it's equal to X. Okay. After that, we always go down and go right. We'll go down first. Then we just say, yeah, we go down first. Then we say I equals I plus 1. Yeah, we always go down. Right? And after that, we need to see we'll go down first. Then we say is previous left is going to be false. Oh, we have to check this. This is fine. And then we check if is previous left. So is previous oh, it's previous horizontal. It'll be easier for me. Hori, right? If previous is hori, then I have to go down. If previous is not horizontal, then I can choose. If previous is not horizontal, then I can go horizontal. If previous is horizontal, then I have to go down, right? So we say if is previous is horizontal, if it's true, then I have to go down. Then with DFS I plus 1 j false, right? And we say if it's true, then we return true. Otherwise, previous is horizontal, I have to go down. If it's false, then we return false, which means previous is horizontal, and now I go vertical and fail. Then I have to go horizontal, and I cannot, then that's a fail, right? Else, if previous is not horizontal, okay? Previous, okay, number of horizontal remain. If previous is not horizontal, then I can decide I can either go horizontal or go down. Let's just go horizontal first. So we're gonna go horizontal. So we say go horizontal first. Alright, we can go. So we say if DFS I j plus 1. Ooh, if I equal to len mat or j equal to len mat I, all this, then yeah. So we're gonna do this. True, previous is, and num left remain minus equal 1, minus 1. Num hori remain is smaller than 0, or, right, I can just do this. If it's this, then we'll return true, right? Otherwise, go vertical. And if DFS I plus 1 j false, right? Num left, no num horizontal. Horizontal remain, right? If this, return true. and if nothing works, return false. Okay, so that's DFS. So we can call if DFS, we start from 0, 0, is previous horizontal is going to be a false. Number of horizontal remain is going to be len mat minus 1. That's the number of horizontal we need to go. And we say we're going to return len mat minus 1 plus len mat if is true. Else we're going to return minus 1. Okay, let's try. We pass. Oh, we failed the first one. The heck? How is that 5? You're tripping. 1 plus 4. Shall be 1, 2, 3. Right, so it's len mat minus 1. Okay. And then, ooh. Yeah, so num vertical num vertical move shall equal to len mat minus 1. Okay. And then num of horizontal move vert. Number of horizontal move 1, 2, 1, 2 shall be len mat minus 1 minus 1. Alright. Then this one can just be if number of horizontal move is larger than number of vertical move, then we do this. This is fine. IJ is fine, right? Because this we're dealing with indices. And here, there's going to be number of horizontal move, right? And then this is going to be number of vertical moves. And number of vertical move plus number of horizontal move. Then we pass this thing. This won't pass. They all pass. Now we need to find this thing. $32. All right, I think we are on to something now, finally. Oh, try. Let's see. Oh no, timeout. Wrong answer. What the heck? Output 9 expected 2. 2. 2. What? Holy crap. This problem is really killing me. Alright, we should call it expected 2. Yo, man, you're tripping. What's the destination? Forbidden A, B, X is 16. Occurs. Oh, yes, the first time it occurs. if temp 0 is equal to x, break. Or we can say while hold on. So I'll break out this whole thing. You know what? Let's just do mat.append this thing. Okay? So we do this and we say if mat minus 1 0 is equal to x, then we just break out. Otherwise, we say, well, true, we do, you know, the regular thing. We say mat minus 1 minus 1, right? If this, then we say mat minus 1 dot append. And if it's equal to x or this, then we break out. I don't want the negative value to be in there, so I break out. And we don't have the append anymore. Maybe we can. You know what? Maybe it will be easier to just add it. You know what? I'll do this. While mat minus 1, 0, minus 1 is not equal to x, and mat minus 1 is larger or equal to 0. While these mat minus 1 dot append mat this minus b, okay? And then go up, I'll say pop out, then we just say if while mat minus 1 is not equal to x. And then we're going to append this, try this, and then we say if mat minus 1 is smaller than 0, I'll just pop. So I don't want a negative value to be there. Minus 1 dot pop. Alright, then we go back up, then we'll come out. Now this one will pass. Really simplified logic, actually. Okay. One more time. This is my last try for today. If it still doesn't work, then screw it. I'm not doing this today anymore. What the heck? I feel like it's either timeout or... Oh, wow. How? Seriously? How? Expected 120. Man. Alright, I said I'm not gonna do it anymore. I'll try this tomorrow. 120. Wow, this is probably the worst I have had in a very long time. Like, seriously. This is ridiculous. What's our target? 1540. 1540. So this is saying, actually, let's also print num vertical move plus num horizontal move. Okay, something is seriously not right. Yep. You do not do one horizontal. You do one horizontal. No. There's another 1540? Oh my. Are you serious? I think there are more. Holy crap. I can't stop at the first one. Oof. Okay. It's I have to try this again tomorrow. Yeah, I need some hint. I'll try this hint tomorrow. Alright, see you guys tomorrow. Adios.